So to start with, I hope you remember this formula, except they've already put in something. They've already put in that. What the heck is that? What's that spot for?
Starting value.
Yes, that's a starting value. All right. And then they also put a number in here. Do you remember what that was? What letter was it before? Okay. So they apparently already know the constant. And since it's negative, can you tell it's decay? All right. That means that it's going down over time. Does it have to be half-life? No. No. This is some sort of a decay, but it's e to the negative 0.07. That's your decay right there. And then what's t? Turnips, right? Time. Okay, good. Now they ask you a couple questions. Don't overthink this. They are different than each other, completely different. Don't think that it's like this and this. They are completely separate questions. Please try it from there. And I get asked a lot, do you need a calculator for this? No, there's no calculators allowed in this test anyways. So don't get your calculator out and actually calculate it. Write the answer exactly, which means it probably has a log in it at the end. Remember, the first part is completely separate and different problem than the second part. I'll pause for a second while you give that a shot. Okay. So when you had this first one, the 8 days, it just had to put it here. And did you have to rewrite it or anything? Do you get that everything over there is a number? Everything inside that box is a number. Why would you want to reshuffle it? It's already got the answer right there. That's the answer. The amount is that. That's it. That's the first part. That's it. If you're trying to solve it for E or something else, E isn't a variable. So that's done. The end. All right. Now, a completely separate question is part B. Part B, we're going to put, when will 3 grams of the isotope be left? Well, then where do you put the 3? Yeah, the 3 goes here. That's where the amount goes. And what could you solve for? T. Everybody do that. Solve it for t. Hint, your answer has a log in it. I'll pause for a second. Let me try that one. Mr. Lindahl, when you put that 3 in here, what was your first step in solving this?
I divided by 15.
Excellent. Did you reduce it to 1/5?
I did.
Good call. And then how do you finish the deal here?
You take the natural logarithm of both sides and then divide by -0.07.
Log base E, aka ln, of the 1/5, because this is a rewrite, and I put that in parentheses to show it's the argument, equals negative 0.07 t. And the final step, Mr. P.
Divide by 0.07.
Yep. Negative 0.07 technically. And I want to see if any of you, maybe you said that, I want to see if any of you looked at that and said, wait a minute, that seems wrong. I did, because I saw that it was negative. Because time can't be negative. But wait, what if ln was negative? That log base E of 1/5, which it is negative. And so then you have a negative divided by negative, which makes it positive again. And
Yeah, it's negative 0.161.
all right. So moral of the story, you can trust, as long as you do this carefully, that you've got a normal time, which will come out positive. So that had to be negative, and then it works out. And that's the exact answer. Remember, a decimal from a calculator is not more exact. It's rounded. Yes?
So even though that's written really weirdly, are you still technically supposed to write days after, like, the unit? Even though it's like,
If you want to be extra careful, absolutely, yes.
even though it's
All right. So we're going to go to this problem right here. And this one's a little bit more like what we did on Friday. You remember these? And what did we do first? We solved for K. I'm going to remind you of that. And n little with the little 0 is your start value. That's like your number at time 0. Now, they tell you everything you need to know in this. Solve for k, and then once you've got that, you write the formula again, except you'll be a little smarter. You'll know what k is. And you know the starting value already. You know that for the first one. But I'm writing it twice on purpose to remind you. You use this formula twice. Once to find k, and then again once you know k to figure out the final answer. All right, this is dense, but it's the best problem that we do today. So take your time, figure it out. You won't even have to subtract those because we have a place for each of them in the formula. You will have to subtract those though. Difficult. All right, pause for a minute. You try to figure out the final answer, which is how many wolves were in Yellowstone in 2002. And the cool thing is this is real world data from the National Park Service using law of uninhibited growth. So like this is actually what you could do in the real world to make predictions. I'll pause for a minute. Good luck. So here's how you do it. The start value was 52. So you put 52 here.
You did that right.
The end value was 118. You put the end values there. The number of years it was 3, from 96 to 99. And then you solve that. So first thing I do is divide by 52. And I got 118 over 52. Could you reduce that? Yes, you could. Let's do that. Half of 118 is 59. Half of 52 is 26. Should you reduce? Yeah, you should always reduce. Now, how complicated the number is may determine whether or not I would take off points for not reducing. But if you see that they're both even, that's a no-brainer. Reduce it. Okay, next I got e to the k times 3, or I'm going to say 3k. Then I'm going to rewrite log base e of, go over here, do circle of logs, 59 over 26. Come back over here, equals 3k. Am I done? No, but close. Now I just have to put a 1/3 in front here, and the 1/3 will take off the 3. And there we go. 1/3 log base e, 59 over 26. And now, is that done? Well, it's done for k. Now I got to go put that in this other equation again. So then my ending value, I don't know. That's the whole point of the problem is the n of t. So I'm going to leave it as n of t. Or I could write the word end. And then the start value was, well, it was the same thing as started with in the first place. There were 52 to start with. E to the k is all that, 1/3. And I was tempted to write ln, and then I realized, ooh, if I write log base e, I'll see that the bases are the same. So I'd always write log base e instead of ln. And then I say 59 over 26, and that's in parentheses. Oh yeah, and then I got to have the t. What is the time in the second part of the problem? It's been 8 years. I'm going to put the 8.
6 years.
Thank you, 6 years. I'm going to put the 6, not here. I'm going to put it here. Because then it makes it more obvious that it just can multiply in with that 1/3. And what is 6 times 1/3? 2. Now, I would expect you to notice that 6 times 1/3 is 2. And you'd simplify that. If you had left it like that, I think I would have been able to give you the credit. But it might be, I'm going to talk to my colleagues, we have to decide whether or not we are going to force you to put that up there. And then notice that the bases are the same, so the answer's already there somewhere. It's there. That is what all of that is equal to. So my preferred answer would be 52 times 59 over 26, all to the second power. And that is how many wolves there would be 6 years later. Any questions about how I got that? How many of you think you can do that? You're going to be good on that kind. Okay, good. So what else is there? Well, you definitely have to know how to condense logs. Let's everybody take a little moment to condense this log. Log base 3 of 25, which is already condensed a little bit, because it could have been 5 squared and the 2 could have been out here, you know. But let's just leave it as log base 3 of 25 plus 4 log base 3 of 2 minus log base 3 of 3. Now remember, the point of this right now is to condense, not to simplify. If it was expand, it would be expand and simplify. And I know the log base 3 of 3 would be 1. But the point of this is to condense it to one log. So I would not change the log base 3 of 3 to a 1 because you're condensing right now, not expanding and simplifying. Pausing while you give that a shot. Okay, so I'm going to pick 2 random numbers. Row 2, person 3. And that is Johnny. Log base, what's the base, Johnny?
Log base 3.
Okay, good. And when you put these two together, what do you know about that process?
It's 25 times 2. Oh no, 25 times 2 to the power of 4.
There you go. You got to put that 4 away first before we pack it all up. And that's 25 times 2 to the 4th. I would have been fine with 25 times 2 to the 4th, just because it kind of shows me where it came from. But if you actually wanted to do it, you go 25 times 16. All right, good. And now I got to put it together with a minus log base 3 of 3. Minus means divided by 3. Raise your hand if you had that one right. Sweet. Okay, that was condensing. How about expanding? Let's go the other way. Oh, question? If you multiplied this all out and got a number, that's fine. Okay. Log base 4 of, let me think, 16x squared all over 3. Let's make it 3y. That's more like what we actually might do on a test. Expand that. And yeah, it's got a lot of little parts. Pause for a sec. Let me try that one. Okay. Some quality help being delivered right now, so I'm just going to write quietly while this help finishes up. And then I'm going to go, because this is divide, I'm going to do a minus. So that's the first step. I took that big divide and I changed it to a minus. Now, this part needs to be split up into 2 logs. The whole point is expand it as much as you can. And so does this need to split up into 2 logs. But I need to make sure that I be careful with this negative right here. So if I'm going to split this up, I might just want to leave one negative here. I'm going to put it in parentheses and say log base 4 of 3 plus log base 4 of y. Or I could have distributed that negative. And this one can be 2 parts. Log base 4 of 16 plus log base 4 of x squared. And that's wrong on 2 levels. Sophia, can you catch where it's wrong? Yes, the little power there, that power of 2 should go down there. I agree with that. Now that distributing that negative, I actually would allow this because this is just factoring out the negative, which is not wrong. So I can allow this to be left this way. I also could totally be happy with you distributing the negative. All right, good. That 16 cannot be left there. What I've tried to train you to do is to look at the arguments and say, okay, now I've got this x fixed, so look, the argument, there's no way to split it up. Is there any way to split up this argument? Oh, yes, there is. Because that could be 4 squared And then I'm going to move the 2 into the front, and then I'm also going to just go, oh wait, that's actually just 1. 1 times 2 is 2. 2 plus 2 log base 4 of x. And I'm okay with this being left in parentheses. But if you didn't have the parentheses, you'd be wrong, because that negative would need to distribute to both of these. That is called expanding. Raise your hand if you had that one right.
She's good at everything. Doesn't
Yeah.
say anything.
Okay. All right. So that's good practice for the Schoology quiz that you're going to have today. And it's not due till Tuesday, though, so you've got some time to get that one done. No, I'm sorry, Wednesday. Two days from now is what I shouldn't have said Tuesday. 2 days from now. All right. And the last thing I got to talk to you about is this formula. Don't worry, we're not going to make you memorize it, but you did actually see it before in higher algebra. This was given to you before. In fact, we even made it more complicated in higher algebra because we had monthly payments, which isn't that hard. You just have to add the payment at the end, but we aren't doing that kind. So I'm going to give you this example. Let's say that you're in your first year of teaching this year as a teacher. Okay, you're a teacher now. We're promoting you to teacher, and you make about $40,000 a year. So 10% of that is $4,000, and you decide to put $4,000 in. And let's say that you get the stock market's average over the past 50 years or so, which is about 7% growth. Now, I hope you get that I'm not saying you will get 7% every year, because that's not how that works. It goes up a lot, it goes down a lot. On average, it has done about 7% per year. N is the number of times it's compounded. Do you know that most things are compounded, or I shouldn't say that. Most payments you have are monthly. Would that be safe to say? So then I'm going to say it's a 12-year. Technically, out there in the banking world, they don't just wait every month and then recalculate your interest. They actually do it on a daily basis. So they don't just like hold on to it for a month. The calculation is slightly different in the real world. It'd be like 365 instead of 12 there. And then the reason there's a 12 times there is so that we can multiply out. If my time is in years, for example, okay, then it's going to multiply it out and make it 12 months for each year times the years. Do you get what I mean? So if this is time of 1 year, do you get that I'm going to get 7% interest then if I do 1 year? Now, can you do 7% interest in your head on 4,000? I can. Sometimes 4 is 28. Is it $280? Is it $28? All right. 10% of 4,000 is 400. So what should 7% be? Well, wouldn't you agree it's a little less than 10%? And if 10% was 400, you're going to get a little less than 400, like maybe 7 times the 4 is 28. But it's not going to be quite that simple because it's compounded monthly. So it's going to be 280 plus a little bit more. So maybe $290 or so of interest. All right. But what do you really, as a teacher, want to save $4,000 just for 1 year? No, you're usually going to do your whole career. So like for me, we figured it out last hour. For 32 years, this $4,000 approximately became 7 times as much. So if this is how it works in the real world, if you put money into an investment, you're saying, I'll come back and not mess with this for like 30 years so that someday it'll be worth more than that. You don't want to put it in there and just get it the same exact thing back out 30 years later, 32 years later. So in my case, it's about 7 times that much, about $32,000 for that first $4,000 that I put in there. So do you get, it would have been very easy to spend $4,000. If I even just said, okay, everybody, just to prove a point, I'm a crazy billionaire and I'm going to give you all $4,000. Do you think you could have it spent before the end of the hour?
Yes.
Easy. Easy peasy. It's because you can just think of something you want and you buy it. Done. Okay, what's harder is to not spend it. And say, if you give me some money, let's say it's $4,000, I'll give you $32,000 back when you're older. And that's the tougher one to do because you're like, well, that means I can't spend it for like 30 years. Yeah, but you get 4 times as much. Or no, sorry, 7 times as much. That's a lot more. Yes?
If it says quarterly, do you put 3 or 4?
Quarterly would be 4. Because it'd be, wait a minute. Okay, wait. What you messed me up with, you're not, I get why you said that, and I may have even answered right. Quarterly means there's 3 months at a time, right? Okay, so, but quarterly is how many times per year are you going to compound it? 4. So quarterly would be a 4.
I thought about that from last year, but I couldn't remember.
Yep, quarterly would be 4. Okay, I think we've got everything that we need to out of this formula. Do you get that you would just put the amount you have up front here, what your interest rate is there, and I'm just talking about investments of like stock. You can actually buy a bond from the U.S. government right now that will pay you about 5%. But that's guaranteed. A bond from the U.S. government. So if you can get like 5% interest, guaranteed by the government, some people choose that because they're like, I want the lock, I want the guarantee. All right. One last thing I'm going to take this moment to teach you is that Ben Franklin had this kind of a moment. He was near the end of his life, and he's a very influential person in our country's history, of course. Ben Franklin had been successful out in the city of Philadelphia, and he ended up leaving $1 million to the town. Would you please write that in the right spot now? He left $1 million to the town. And he said, I want you to invest it. And let's say that we do this in modern times, and the stock market is probably how you do it in modern times. They didn't have a stock market back then. They had other things they could invest in, but and let's say that you get that 7% growth, compounded monthly. But what he did that was different than anybody I've ever heard of before is he said, I'm giving this to the city of Philadelphia with these strings attached. You have to keep it invested the whole time. You can't spend any of it for 100 years. Because exponential growth goes a little crazy after 100 years. So we've got 1 million here. We've got 0.07 here. We've got it monthly, so you should have put a 12 here and here. But the crazy part is he made him wait 100 years to get it. So now that $1 million grew to many hundreds of millions of dollars. That's a lot of dough. I did have some hiccups along the way. Somehow they couldn't figure out how to invest it for a couple of years. Not smart management, because like having that much money not growing was a really bad idea. But in the end, there was a lot more money there than there was in the first place. And of course, I'm sure along the way, some people were like, let's just spend it now. Like we need to spend it. Well, then you wouldn't get to the end. You wouldn't have that big, large payoff at the end, because this is what I'm trying to get across to you. You are going to be investing some money over a long period of time, and it'll exponentially grow. It will be very tempting to take it out right here because, oh, it grew something, and all of a sudden my money that I put in is worth enough to buy a boat. Or I could just I could go on a trip around the world. And you spend all your money and then you start over again. And you'll never get to that very large amount at the end. I actually did the math on it and figured out that each year you wait to start saving costs you about $92,000 later. So do you get there's always going to be a reason to wait? Like, I can't put the $4,000 in. I got to buy a new car. Okay, and all of a sudden, now you've got the new car and you've just wasted a ton of money buying a new car where you could have got a used car. But you've got your car, now you can start saving. Oh no, I can't save now. I want to buy furniture. And then next one is, well, I'm thinking about having kids, so I can't save any money now because kids are expensive. And then you have the kid, and now you should start saving for not only you, but for their college. And then it's really tempting to go, but I've worked so hard. I deserve a nice vacation. And I'm not saying you should never spend any money. I'm just saying you have excuses for the rest of your life why you shouldn't save now. I should save later. Someday I'll start saving. And each year you wait, you're costing yourself $92,000 because of this. Because when you chop off years, you're not chopping off years at the beginning. You're actually chopping off years at the end. Those years when this would have grown $92,000. Because when you chop off a year, you don't get that end that you would have had. So, there's my big picture talk about you should save so that someday you can have enough money to be, I don't want to say retire, because I, for example, don't want to retire. I want to just quit and watch TV. But I like having the freedom to retire if I want to, because I don't have to go do that job that maybe some days is hard. Okay, so anyway, that's how you'd use that formula. And now I just want to do a little bit of review with you by having you start the Schoology quiz. I think some of you will even finish it during class. But your real homework is, seriously, if you want an A on this test, it won't come down to the Schoology quiz problems. Those are kind of easy. It'll be one of these word problems. So I would recommend that you did 2 of the word problems on yesterday's homework. Do the next 3. Add 3 more. And the reason that you may not want to finish up the Schoology quiz right now is the Schoology quiz isn't due until the test. Okay, so you have 2 more days to get the Schoology quiz done. Please, for your own good, go do some word problems, because there's only 4 hard problems on the tests, and I'm sure one of them is going to be a word problem like we've been working on here. So only 4 hard problems. And those are usually, almost everybody gets 3 out of 4. Of the easy ones, there's 8. And almost everybody gets 6 out of 8 of the easy ones. That's not that hard. What's hard is getting 3 out of 4 of the hard ones right, which are like the word problems. So you'll all do fine on the easy part. And I want to make sure of that by doing the Schoology quiz, because those are kind of the easy ones. There's a couple on there that are kind of like easy R3s. But if you really want to see what an R3 is like, add 3 more word problems to last night's homework. That's the same as last night's homework, where we said only do the first 2. Now do 3 more, okay? And then you'll be really ready for this test coming up. I do have a full day of review tomorrow, and then the test is Wednesday. All right, that's all I got for you for today.